In this lesson, we will define statistical measures that are useful in comparing one set of data with another. For example, grades in two classes, scores on two tests, or the performance of two students. We will answer 3 questions in this lesson. What is a percentile? What is the normal distribution? What is a z-score? Here is an example to motivate our lesson. Suppose John took tests in 3 classes and received a 60 on all 3 tests. Looking at course material, John was told that he was successful on 60% of each test. But John wants to know how he did compared to other students. What would you say to John after looking at the 3 sets of course grades? Test 1, 50, 60, 70, 70, 70, 80, 90. Test 2, 40, 50, 50, 50, 60, 60, 70. And Test 3, 60, 80, 90, 90, 90, 100, 100. Dot plots are helpful here. On Test 1, John was one of the lowest scores, but just below the middle. On Test 2, John was one of the top scores, just above the middle. Finally, on Test 3, John was the lowest score and well below the center. Percentiles are standard scores that have the same definition for each test and help John understand how he did compared to other students. A percentile is the percent of scores that were the same or lower than any particular score. For John, on Test 1, 2 scores were the same or lower than his out of 7 scores, which equals 0.286, which is the 29th percentile. Test 2, 6 scores were the same or lower than John's out of 7, which equals 0.857, the 86th percentile. Finally, on Test 3, there was only 1 score that was the same or lower than John's out of 7, which equals 0.143, the 14th percentile. Compared to other students, John's 60% correct was a high score on Test 2. Only 1 student, or 14% of the students, scored higher. In the table are the math and reading EOG results of a class of 3rd grade students. They are reported as scale scores. Liz scored a 339 on the math test and a 367 on the reading test. The scales on these 2 tests are different and should not be compared, but we can find out how Liz did compared to her classmates on each test. First, make a dot plot of each set of data. Pause the video as you do this. The dot plots show that Liz's math score is a middle score in math, but she had the highest score in reading. On the next slide are her percentiles. Make a guess at what the percentiles are and then calculate them before looking at the next slide. Pause the video. Liz's percentiles show much better comparative performance in reading than in math. In reading, all the scores were the same or lower than her score, so 20 divided by 20 is 1, or the 100th percentile. In math, 8 of 20 scores were the same or lower, which gave her a percentile of 40. 60% of the scores were higher than her score. On the end-of-grade frequency report that we studied in Lesson 4, note that the scale scores for the percentiles 10, 25, 50, 75, and 90 are given. These are the percentiles for Wake County Public School System Grade 5 Mathematics in 2008-09. Students who scored a 371 had 10% of the students score higher than them. Remember that the 5-number summary includes the 25th, 50th, and 75th percentiles. These percentiles are quartile 1, the median, and quartile 2. In Lesson 2, we define the distribution of data as the pattern of the variability of a variable collected on observational units. We also define 3 classes of distributions. Class A was a symmetric distribution since right and left sides were approximately mirror images of each other. A symmetric distribution can also be mound or bell-shaped, as the one here. The most well-known symmetric distribution is the normal distribution. Many variable measures of large populations of people are distributed normally. When working with student test scores, we assume the underlying distribution is normal, and so use the properties of normal distributions that we will explain here. Here we use the Greek letter sigma for the term standard deviation. The percentages represent the amount of data points that occur within 1, 2, and 3 standard deviations from the mean. Our rule of thumb is that 68% of the data are within 1 standard deviation of the mean, 95 are within 2 standard deviations, and 99.7%, nearly all the data, are within 3 standard deviations of the mean. Is there another way to answer John's question about how he compared to other students on each test if each teacher tells him the mean and standard deviation of their class? Yes, we can convert John's 60s to another standard score called a z-score. Z-scores use the mean and standard deviation and assume that the underlying data is normally distributed. A z-score is the number of standard deviations a score is from the mean of all the scores. For example, if the mean of a set of scores is 70 and the standard deviation is 10, a score of 80 would convert to a z-score of 1 because 80 is 1 standard deviation above the mean. A score of 60 has a z-score of -1 for 1 standard deviation below the mean. Here is the formula and the substitutions needed to find the 1 or -1 described on the previous slide. It must be the score minus the mean in order to have a positive z-score for scores above the mean and a negative z-score for scores below the mean. Now, back to John's test. The z-score for test 1 is -8/10, 60 minus 70 divided by 12 9/10. This means that John's score was 8/10 of a standard deviation below the mean. Test 2, the z-score was 6/10, 60 minus 54 3/10 divided by 9 8/10, which means John's score is 6/10 of a standard deviation above the mean. Finally, on test 3, the z-score was 1 96/100. 60 minus 87 1/10 divided by 13 8/10, or almost 2 standard deviations below the mean. Remember that the standard deviation is the average deviation of scores from the mean. So on test 3, John's score deviated twice the average deviation from the mean. To practice, find the z-scores for each of Liz's scale scores. You must first find the mean and standard deviation of each set of scores. Review lessons 3 and 4, part 2, if you need help here. Pause the video. The graphs show that Liz's math score is a middle score in math, but she had a very high score in reading. Her math z-score is -1/10, 339 minus 340 divided by 12 2/10, slightly below the mean. And her reading z-score is 2.0, 367 minus 340 3/10 divided by 13 2/10. This is well above the mean. On the Integrated Frequency Report, we see that 10,416 Wake County Public School System students were tested on the Grade 5 Mathematics test in 2008-09, with a mean of 358 48/100 and a standard deviation of 9 42/100. Assuming a normal distribution, we can standardize these scores by changing them to z-scores. See the next slide. This illustration shows that the mean, 358 48/100, becomes a z-score of 0. Adding and subtracting the standard deviation of 9 42/100 finds the scale scores that are associated with the z-scores -4, -3, -2, -1, 1, 2, 3, and 4. We can see that student scores between 349 and 600 and 367 and 9/10 are within 1 standard deviation of the mean. These are the most likely scores in Wake County Public School systems on this test. For scores that are normally distributed, we can easily associate the scores with percentiles. The mean is always the 50th percentile. The score 1 standard deviation above the mean has 50 plus 34 for 84% of the scores below it. It is the 84th percentile. Label the other scores with their percentiles. Remember, a percentile is the percent of scores the same or less than a score. Round to the nearest whole percent. Pause the video. Here are the percentiles rounded to the nearest whole number. Since the percentiles for -3 and +3 round to 0 and 100, we know that almost all scores are within 3 standard deviations of the mean for normal distribution. We can use the normal distribution in z-scores to compare the two teachers described here. Since we know that their grades are normally distributed, we can answer the question: which teacher gave more F's? Which teacher gave more A's? See the next slide. By using the mean and standard deviation and the symmetric properties of the normal curve, we can see that teacher 1 has 16% of the grades in both the A and F category, 1 standard deviation from the mean. So teacher 1 gave 5 A's and 5 F's. Teacher 2 had only 2% of the grades in the A or F category, 2 standard deviations from the mean, and so gave only 1 F, but also only 1 A. This concludes Lesson 5. You may want to spend more time studying each slide since these are more complex concepts. Can you answer the 3 questions in this lesson? What is the percentile? What is the normal distribution? What is a z-score? The final lesson is Lesson 6. It explains correlation, standard error, and confidence interval.